The next thing is applications of the addition formulae. So we want to use them to solve other kinds of problems. So we'll just start with this question, which I think is quite nice. Without using a calculator, show that cos of 75 degrees is root 6 minus root 2 over 4. So the issue here is 75 degrees is not a special value. We don't know. This isn't probably something you've seen before, but we can use the addition formulas to prove it, because we can split up 75. We can write it as, can you think of two special angles you know that sum to make 75? And hopefully you're thinking of 30 and 45. Another thing you can also do is think about two angles whose difference is 75, that are also special angles you know. And then we use the formula for cos A plus B. So this is cos 30, cos 45 minus sine 30, sine 45. And then just think back to GCSE, and I'm sure everyone remembers cos 30 is root 3 over 2, and cos 45 is root 2 over 2, and then sine 30 I'm sure you know is a half, and sine 45 is also root 2 over 2. And then we're pretty much done, because root 3 times root 2 is root 6, and that's over 4, and then this is minus root 2 over 4, and we're done. There we go. Okay, so on to a harder example. So given that the angle A is between 180 degrees and 270 degrees, and sine A is minus 3/5, and cos B is minus 12/13, and B is obtuse, the question is find part A, cos A minus B, part B, tan A plus B, and part C, cosec A minus B. So there's quite a lot to do. So let's just start by thinking about what we need to find cos A minus B. So there are four things we need to find this. We need this. We also need cos A and sine B. So can we work out cos A and sine B? Should be the first thing to think about. And we know cos and sine are related, so there are various ways of working out what they are. One is to think about a triangle. So we know sine A is minus 3/5. So that corresponds to a 3, 4, 5 triangle. So we're expecting cos A to be either 4/5 or minus 4/5. But which is it? Well, it all comes down to this. We're given that A is between 180 and 270 degrees. So in a cast diagram, 180 is here, 270 is here, so we're in this this T section. The angle A is in here, so the only thing that's trig ratio that's positive for A is tan. So cos is going to be negative. So we can say with certainty cos A is minus 4/5. And it's worth pointing out there are other ways you can work out what cos A is. You can use sine squared plus cos squared equals 1, for example, and rearrange. But you still have this issue about sine, whether it's plus or minus. So again, you have to use this cast diagram or the graph or something like that. And then for B, we need sine B. B is obtuse. Obtuse means between 90 and 180, so that's in S. So sine B is going to be positive. So again, cos B minus 12/13. So we're thinking about this triangle, which is a 5, 12, 13 triangle. If you didn't know that, then the way to find 5 is obviously root 13 squared minus 12 squared. Just use Pythagoras. And then sine B is going to be plus 5/13. And again, it's a plus because an obtuse angle is in the S quadrant. Okay, so we've got everything we need. So now we can find cos A minus B. So using the formula that's given in the formula book, this is cos A cos B plus sin A sin B, which is, and now we've got everything. Cos A we just found is minus 4/5. Cos B we were told is minus 12/13. Sin A we know is sin A is minus 3/5. Sin B is plus 5/13. And then we can say all over 65, this is plus 48 minus 15, which is 33 over 65. And then the next one was tan A plus B. So now we need tan A and tan B. So tan A is sin A over cos A, which is minus 3/5 over minus 4/5, which is 3/4. And tan B is sin B over cos B, which is sin B is 5/13. Cos B is minus 12/13. This is minus 5/12. And therefore tan of A plus B is tan A plus tan B over 1 minus tan A tan B, which is 3/4 minus 5/12 over 1 minus 3/4 times minus 5/12. And now if I just times everything, you could just enter this in your calculator now and it'll give you the answer, but because I don't have a calculator, if I times everything by 48, that will eliminate all the denominators, so we're going to get, in fact, we could make it easier. If we just do some cancelling here, we can now times everything by 12. That's much easier. So we're going to get a minus 5 here. If we times 3/4 by 12, we get 9. 1 times 12 is 12. Oh no. We don't want to times by 12. Because then we're going to get 60 over 16, which is, oh well, I've done it now. 60 over 16 is 15 over 4. And then if we times everything by 4, we get 16 over 48 minus 15, which is 16. Oh, this was a plus, wasn't it? Sorry. This is a plus over 63, because it was minus times minus. And then lastly, cosec A minus B. So cosec, I believe you've met by now. Cosec is 1 over sine. So this is 1 over sine A minus B, which is 1 over sine A cos B minus cos A sine B. And then we can just put the numbers in. So we know sine A is minus 3/5. We know cos B is minus 12/13. We know cos A is minus 4/5. And we know cos B is, was it 5/13, I think? Let's just check. Yes. Okay, so, and then if we times everything by 65, we've got 65 over 3 times 12 is 36, plus 20, which is 65 over 56, which does not cancel. So that's the answer. Done.